Hello everyone, my name is Frank Fan. I'm a specialist solution architect from AWS. Today, my colleague Chen and I will deep dive application modernization patterns with VMware Cloud on AWS. Imagine you are working in an environment which have lots of challenges here. Firstly, the customer wants to migrate a large amount of volume of VMs to cloud quickly. At the same time, their application development team want to improve the application architecture so they can fast-track their application development lifecycle. Thirdly, both teams don't want to cause business disruption. They want to make this transformation as smooth as possible. In today's session, we are going to cover why microservices and container technologies. And we are going to walk you through some patterns and give you some examples to decouple monolithic applications to microservices. And thirdly, Sheng is going to demonstrate an example. Why microservices? First of all, we need to ask a question. What's the business outcome is going to drive this change? Do we have any other method to deal with challenges, such as improve the organization structure or improve the collaboration between teams? Is modernization of application is the only approach, or you can combine it with other approaches? What are the scope in the project? What's the volume and time frame we are working on? And it's very important to understand what knowledge do you have within the team about application. Do you feel comfortable to refactor the application? Regardless what decision you are going to make about your transformation or you just lift and shift, each decision has some consequences you need to be aware of. For example, if you want to do the application modernization, you may need to think about how I'm going to do the monitoring. How about logging? If I have issues with application, where I'm going to start to troubleshoot this issue? If we compare monolithic versus microservices, this diagram shows 4 big shapes which represent the components inside the application. For example, you may have multi-tier applications. You have that round circle as a core application component. That triangle represents the web frontend. So monolithic, it pretty much have all the components bundled together inside that VM. Microservices, you break them into smaller pieces. Perhaps you're running each piece inside a container environment. One of the benefits for microservices is, compared with monolithic, it's more flexible and give you an opportunity to isolate, have provided that isolated environment. For example, if you have security bugs or issues you need to deal with quickly, you can just handle that specific component which have that issue. It doesn't like monolithic application. Potentially, if you have one issue of one component, it can potentially bring down the whole VM. But for containerized environment, it's isolated, so it won't impact other components. It's more flexible. Let's imagine this is a 3-tier applications. You have web frontend represented by the triangle. In a monolithic architecture, because it's seasonal workload, you have lots of demand coming in. During that time, you need to scale out. You have to scale out the equivalent number of all the components. But for microservices, you have flexibility to scale out just the web frontend. right, represented by the triangle, you can bring more of web services, but still leave the backend application as is. Monolithic and microservices, they all designed for some reasons. Monolithic is a way, if you have that architecture on premises and you want to do the migration to the cloud, you may want to stay with that architecture because it can make your change minimal, so you have that consistent performance and architecture. But in this specific situation, the customer, the developer team really want to embrace the architectural microservices because they want to make change quicker, they want to release new features to the market as soon as possible. Can we have the benefit of both? That's a big question mark. The answer is yes. So we are going to introduce a new pattern, this hybrid pattern. As you can see, the star represents the core functionality of your application. We still leave it as is. And we just break down that triangle, that component into small pieces, and run that small pieces in a containerized environment. So that part of work can be done by the developer team. They can release new features quickly, but at the same time, the main functionality continue work as is. So both teams are happy. We just talked about the hybrid pattern. Let's see how we can leverage VMware Cloud on AWS to enable you to leverage that pattern. You have on-premise environment on the left-hand side, and you want to migrate to the cloud. The step one, because you have large amount of the data and volume to migrate across, and you don't want to minimize the change. Leverage VMware Cloud on AWS, which is a cloud service delivered and managed by VMware. It's running on AWS infrastructure. You continue using vCenter to manage the environment and leverage vSAN as storage virtualization platform and NSX to create that logical network for your VMs. Because it's on the AWS infrastructure, so it has high bandwidth, low latency link connected to other AWS native services. We can leverage Amazon EKS, Elastic Kubernetes Service, to be your containerized environment and integrate with your core applications. You can continue on this journey with other steps if you like. How to containerize your application? First of all, we need to understand the patterns here and approach. You have monolithic applications. You can choose to relocate using VMware Cloud on AWS. No change about the architecture at all. Or you can choose other AWS services to re-architect your applications. But it's not one or the other. You can combine the benefit of both. So relocate the core functionality, but you can re-architect some components if you like. So this is the combined approach with hybrid pattern. This is the customer journey I have been working on with them very closely. The customer have lots of data centers they want to consolidate to meet the compliance requirement. They didn't have the time to re-architect the applications, so they decided to lift and shift to VMware Cloud on AWS. And then they embrace other services to combine them together. For example, they leverage the EKS to provide their containerized environment to integrate with their core app databases, still running inside VMware Cloud on AWS. They also have options to leverage EC2, Amazon Elastic Compute Cloud, or AWS Lambda function. In terms of containerization, AWS provides this tool called app to container. It's very simple command line tool. So start with left, you have all the sources you can start with. Step 1, pick up your applications. App to container supports ASP.NET applications and Java applications. When you select them, you package them up, all the artifacts, and put them in the container images, such as Docker. And step 3, you set up your networking ports and spin up your tasks inside your AWS container services, such as EKS or ECS, Elastic Container Services. But it's not finished yet. It also provides lifecycle management. So using CloudFormation to provision all these software stacks and your pipelines to have that CI/CD platform built for you. Let's deep dive into this hybrid pattern. Imagine this is a multi-tier applications. We have 4 different shapes represent different functionality. There could be web front end, it could be a shopping cart. And then have databases attached to this single VM. We place an application load balancer in front of this VM. Step 1, we remove the triangle from this core functionality. The triangle could be a shopping cart function. Luckily, we have application load balancer. We can define rules. If you have URL end with /cart, the traffic will be redirected to this triangle. The same concept applied to other components. We can also remove another function out of this core application. And then you apply different path-based rules in the traffic. As you can see, this method can easily decouple the components from this core functionality, and you can continue using the core functionality without any change. Now let me hand over to my colleague Sheng to demonstrate an environment.
Thank you, Frank. Hello, everyone. My name is Sheng Chen. I'm a specialist solutions architect focusing on VMware Cloud on AWS, or VMC. Today, I will walk you through a demo that is based on the hybrid pattern that Frank discussed previously in the session. In this scenario, we have just completed a lift and shift migration of a monolith application stack, including a Postgres database virtual machine from on-premises data center into the VMC environment. Now, let's say the developers from customers' team need fast access to a Kubernetes platform to help them transform existing apps into microservices. However, they don't necessarily want to go through a database migration process due to the time constraints. And they also need a fully managed Kubernetes solution without the complexity for managing and operating their own clusters. This is where we could leverage the high bandwidth and low latency Elastic Network Interface, or ENI, and integrate VMC with Amazon Elastic Kubernetes Service, or EKS, to build a hybrid architecture. In this particular example, we'll take a look at how easily we can deploy and manage the web and app container workloads within a fully managed Amazon EKS cluster, while keep the existing database VM running on VMC to avoid database migrations. I also show you how we can leverage the Kubernetes ingress controller in conjunction with a network load balancer to intelligently and efficiently expose the web microservice onto the external network. For the second part of the demo, we'll go through a sample CI/CD pipeline, which leverages cloud-native DevOps tools such as AWS Code Pipeline, Code Build, and Elastic Container Registry, or ECR, to automatically build a new version of the web microservice and deploy it onto the existing EKS cluster. This example demonstrates how we can help customers to improve their software development lifecycle and to enable developers to easily try out new ideas and further accelerate their application modernization journey. So let's get into it. Moving to the demo environment, this is a simple guestbook message board application. The application consists of a web tier and an app tier, both running as container-based microservices. Each microservice is deployed as Kubernetes pods on a pre-provisioned Amazon EKS cluster, which is sitting in a sidecar VPC connected to the VMC cluster. So we can leave a test message here at the home page of the demo app. And the data will be written into the Postgres VM running on VMC via the high bandwidth, low latency ENI. Now let's take a look of the EKS cluster. As you can see, we have a 2-node cluster here, and we are running 4 pods for the guestbook application. 2 for the web/UI tier, 2 for the app/API tier. And this is because for each tier of the microservices, I have created a Kubernetes deployment configuration asking for 2 replicas as the desired state. And this means Kubernetes will always try to match that desired state for as long as we have resources available in the EKS cluster. Based on this, we can test the Kubernetes self-healing capability by deleting one of the pods here. For example, we could take out this UI pod and observe the behavior. We can see almost immediately a new UI pod has been launched to keep the desired state of 2 pods as specified in the deployment file. So this was the pod just got deleted. And this is the new one that's automatically recovered and launched by the EKS cluster. Now let's explore the API deployment config. Here we are leveraging the standard Kubernetes environment variables to pass on the Postgres database virtual machine details, such as IP addresses, database names, etc., to the API ports. To verify this, I have logged onto the vCenter in the VMC lab environment. And here is that Postgres VM we are connected to. That is also deployed under the VMC SDDC cluster. Notice that the IP address here is the same as we specified in the API deployment config. And here I have a database manager client connected to the same Postgres VM instance. And if I refresh the table here, we can see that the latest message we just left there has been indeed pushed through to the database via the API ports running on the EKS cluster. So how did we publish the web microservice to the internet then? Here we are leveraging a standard Kubernetes ingress feature, which is integrated with the AWS Network Load Balancer to expose the web service externally. we can see it's configured with my VMC demo domain FQDN under the root path, which points to the guestbook web/UI service. We can also verify this on the AWS console. So here's the load balancer, end with 7C29. And it's the same one as we seen in the console. And we can tell it's forwarding the inbound traffic to the Kubernetes ingress running inside our EKS cluster. In fact, this network load balancer was automatically provisioned by Kubernetes API through the deployment of that Nginx ingress controller. So with this model, we can provide a layer 7 host-based or path-based service routing through a single network load balancer, which significantly reduces the consumption of additional load balancers and the elastic IPs and increases operational efficiency. In the next part of the demo, we'll take a closer look of a simple two-stage CI/CD pipeline, which is deployed through the AWS code pipeline. And this is configured with a build trigger that is linked to the guestbook UI source repository, which is hosted on my GitHub account. To trigger the pipeline execution, I make a version change to the home page of the guestbook UI, and then save and push the change to GitHub. As we can see, the version 1.1 commit has just been pushed to GitHub, and this should automatically trigger the pipeline run as well, which is happening right now. And from the link here, we can also verify the committed change details from the source repository. So the pipeline is now in the build stage, and we can monitor the live build logs at here. We can also review all the detailed build steps from the build spec file. And what's happening here is that AWS code build will launch a Docker container and download all the required packages and dependencies to prepare for the build. Once ready, it will build a new Docker container image with the latest commit from the Git source repository. Code build will also tag the new image with a certain format, which includes the timestamp of the build, and then push the new image to the Amazon ECR registry. And finally, it will evoke kubectl command line tool to set the guestbook UI deployment with the new image from ECR. Now let's come back and monitor the build process. So the build process just completed, and the new Docker image has been uploaded to ECR. And if we switch to ECR, we can find the latest image that was just pushed through. We take a note of the timestamp here. And from the EKS cluster, we can verify this from the deployment rollout history. And we can confirm the recent Kubernetes deployment has updated the UI pod image to the latest one from ECR. And if we refresh the browser, we can see the home page has been indeed updated to version 1.1. So to summarize, in this demo, we have walked through a real example of building a hybrid microservice application by integrating VMware Cloud on AWS with Amazon Elastic Kubernetes Service. We have looked at how to leverage some of the native services, including Cloud DevOps tools, to improve and accelerate the software development lifecycle. I hope this has been informative. Now back to you, Frank.
Thank you, Sheng. Sheng just walked through how to decouple monolithic applications into container services. And let's recap what business outcome we achieved. Firstly, we leverage VMware Cloud on AWS, so you simply lift and shift your application and databases with the same technology. You don't need to change your applications, and then the core functionality is continuing working. You can continue using your tooling, runbooks, and processes to manage the environment. And you innovate with hybrid pattern. So the core functionality still stays there, but you decouple some of the components using container services. As a result, both teams achieved what they want, and they can collaborate and learn from each other, and also open for opportunities for future enhancement. If you want to know more about this approach, check out AWS blog articles and reference architecture. And you can also visit the Application Resource Hub and also the training and certification information here. Thank you for watching.